I'll go ahead and give you my disclaimer one last time. You should only be watching this video if you have exhausted all other resources. Task 5, Question 4, the last question. In this problem, a more challenging hole is located at the coordinates 100, 0. If the ball is hit with an initial velocity of 95 feet per second, determine the two angles that would result in a direct shot into the hole. So again, just like in question 3, I don't know all of the information. But in this problem, I know the velocity, but I don't know the angle that I want to hit the ball at. But our approach is going to be the same. We're going to start by writing down our models in terms of the unknown variable and our parameter t. Once I have my model, I want to go ahead and eliminate the parameter to combine this set of parametric equations into a single equation. So I'm going to solve my x equation for t by dividing by 95 cosine of theta. I can then substitute this value in for t in my y equation to eliminate the parameter. Let's do that now. Notice that the substitution worked the same way it did in the last problem, and I can again simplify the 95 over 95, the initial velocity, and I can also simplify the sine of theta over cosine theta and write it as tangent of theta. Just as in the previous problem, I'm now going to substitute in the point that I know has to lie on this graph. That is the coordinate of the hole. In this problem, the coordinate of the hole is 100, 0. So I'm going to substitute that in for x and y. As before, since the left side of my equation is equal to 0, I'm going to treat that as its own function and call it y. And I'm going to change my unknown value, in this case theta, to an x. So change it to cosine of x and tangent of x. And now all I need to do is graph this and calculate, in this instance, both x-intercepts. Now if you watched the last video, you may notice that we had a little bit of trouble finding a good window. However, what's nice about this problem is that we know our answer has to be between 0 and 90, since we were talking about the angle of the launch, and it wouldn't make sense for a launch angle greater than 90. So all I have to do is set my x min to 0, my x max to 90, and since we know we're looking for x-intercepts, I can set my y min to -10 and my y max to +10 to ensure that I can find them. If I do all of that, I can graph it, and I should end up with the following graph. Notice that the top of the graph is cut off, but that doesn't matter because I'm merely interested in these two x-intercepts. So as before, we can second calculate 0 and make sure we put our left bound and right bound in the correct spot to find not one solution, but our two solutions of the two possible angles that would result in a direct into the shot hole, being theta equals 3.313 degrees as one option, and theta equals 79.845 degrees as the other possible solution. That does it for these problems. I hope you had fun and learned a lot.